Our next topic will be reflections in the plane. So what's a reflection? A reflection is a transformation representing a flip of the figure over a point, line, or plane. If we were to look at let me get the pointer on. If we were to look at a point and we wanted to reflect that point over a line, alright, we need to make it flip to this side with the same distance between the point and the line. So whatever distance this is has to be over here before we put our point. Now it's important to realize, let's change the color, that the line running through the reflected point is perpendicular to the line we reflected over. Right? These have to be in that same line. Right? The same distance, the same line for it to be reflected. So let's look at some different lines that we're going to reflect across. So we're going to reflect across our x-axis and our y-axis. We've already seen a little bit of reflecting over the x-axis with our parent functions. But let's look at reflecting the point A, 4, 1 over the x-axis. So first, let's plot our point. So we'll go 4, 1. So this is our A. Alright, and we want to reflect over the x-axis. So since we want it to be perpendicular, we know it's going to have to stay right on this line of y equals 4. And we want it to be the same distance. So the distance from this point A to the line to our x-axis is 1. So we'll go from our x-axis and go down 1 to find our A prime. So our coordinate for A prime is 4, negative 1. 4, negative 1. So anytime we flip over the x-axis, it's going to stay with the same y value and just go the distance, however far it is from our x-axis on the other side of the x-axis. So we can write a rule. Alright, looking at our pre-image and our image, the pre-image goes from 4, 1 to 4, negative 1. So our x value stays the same because it's still at x equals 4. Right? The only thing that changes is our y. It goes from a positive 1 to a negative 1. So the rule we have for reflecting over the x-axis is just xy becomes x negative y. Our y becomes the opposite. Alright, so now let's reflect that same point over the y-axis. So now we're going to be reflecting over our vertical y-axis. Well, we have to keep a similar mindset. We have to keep it on this perpendicular line, so it's got to stay at our y equals 1, and it's got to be the same distance. So our distance from A to the y-axis is 4, so we'll go to our y-axis and go 4 in the opposite direction. So our A prime is now at negative 4, 1. So just like with our x-axis, we can make a rule for reflecting over the y-axis. So our pre-image 4, 1 becomes negative 4, 1 in our image. So our xy becomes negative x, y. So we can use this rule if we don't want to graph. So we can say, looking at the point negative 2, 2. If we want to reflect it over the x-axis, sorry, this is so terrible. If we want to reflect it over the x-axis, we would simply go from xy to x negative y. So it would become negative 2, and then our 2 would become negative 2, opposite. Alright, if we wanted to reflect it over the y-axis, our negative 2 would be opposite because we would go from xy to negative xy. So it would be 2, and then our y would stay the same. Alright, so we can also just look at other vertical and horizontal lines. So not on our axis, just somewhere else. So we can reflect 2, 2, and we'll call this A. So we can reflect our point A over y equals 1. So first let's graph A, 2, 2. Alright, we're going to reflect it over y equals 1. So we go to y equals 1 and do our horizontal line. So to reflect over y equals 1, we need to look at our perpendicular line and go the same distance. So from our point A to y equals 1 is 1 unit. So go on the other side, 1 unit would put us our A prime down here. So our A prime is 2, 0. 2, 0. Alright, so then, let's change the color. We're going to take our same point A, 2, 2, and reflect it over x equals 3. So let's go to x equals 3. We're going to draw a vertical line. Alright, and we're going to do the same thing. We're going to look at our distance from our point A, our pre-image A, to our x equals 3 line. Alright, so that is 1 unit as well. So now we want to go on that perpendicular line. So it's going to keep us on that same horizontal path, and we're going to go 1 unit on the other side of our line. So our A prime is now at 4, 2. Our A prime is at 4, 2. Now let's look at reflecting a point over the line y equals x. So first we know y equals x is a slope of 1, and it starts at 0, 0. So our line looks something like that. So this is a little different than we've been doing. We've just been doing vertical and horizontal lines. So now we're going to look at a slant. So our point is negative 1, 4. Alright, this is our pre-image, A. Okay, so if we're going to reflect over the line y equals x, that means we need to have a point on the other side that's perpendicular and the same distance. Now it's kind of hard to get the same distance from a slanted line. You might not always have a nice slope. So one way we could do this is just count down 4 over 1. Get to a nice point. 0, 0 is usually a pretty decent point. So to get to 0, 0, we had to go down 4 over 1. Now we're going to flip it and do the opposite. So we'll go down 4 over 1, then down 1 over 4. And this is our A prime. So if we look at our line, our perpendicular line will go right through these 2 points, and you can kind of see how it's the same distance looking at your grid. So our A prime coordinate, our image, would be at 4, negative 1. 4, negative 1. Okay, so if we look at our pre-image and our image, we go from negative 1, 4 to 4, negative 1. Well, that's another pattern that we can write a rule. So if we take our coordinate x, y and reflect it over the line y equals x, all we do is we switch it. So xy would become yx. xy would become yx. Alright, so now let's look at reflecting over y equals negative x. So if we graph y equals negative x, it's going to be a slope of negative 1, starting at 0, 0. Alright, and we have our pre-image of A at negative 1, 4. So here's our A. Okay? So if we do something similar like we did with y equals x, we go to 0. So to get there, we have to go over 1, down 4. So now we can go over 4, up 1. So our A prime is on that perpendicular line with our pre-image, and they're the same distance from the line that we're reflecting over. So the coordinate of A prime is -4, 1. And once again, we have a relationship. Our pre-image goes from -1, 4 to -4, 1. So we can write a rule here that to take the coordinate xy, x comma y, and reflect it over y equals -x, we'll simply take a -1 and 4, flip, right? Because we have 4, 1 here, and then our +4 becomes a -4, and our -1 becomes a +1. So it's opposite. So we have -y, -x. So xy becomes -y, -x. Okay, now let's look at one more. So far we've been looking at points reflected over lines, and now we're going to look at a shape reflected over a line. So we've got quadrilateral JKLM with vertices J at 2, 2, K at 4, 1, L at 3, -3, and M at 0, -4. And we're going to reflect it over y equals x. So first let's graph our points. So we've got 2, 2, that's our pre-image J, 4, 1, that's our K, 3, -3, that's our L, and 0, -4. That's our M. Alright, so if we connect those, we get a quadrilateral. Alright, next we're going to graph our y equals x, right? The line that we're reflecting over. So we'll start at 0, 0, got a slope of 1. Okay, so now all we're going to do is take each point and reflect it over. So if we look at J, it's on the line, so it's 0 units from our line that we're reflecting over, so it's not going to move. Let me change colors. Alright, let's pick red. So it's going to stay the same, so that's also our J prime. Alright, our K, we go down 1 over 4 to get to 0, so we go up 4 over 1. There's our K prime. Alright, our L, we go left 3, up 3, so over 3, up 3. So then we'll go over 3, up 3 to get over here. So this is our L prime. And then to move our M, we're going to go from, we'll say up 4 to get to 0. So then we'll go over 4 to get to this side. So that's our M prime. You can always double check, make sure that your points line up and are perpendicular to our y equals x. So everything's perpendicular and it looks like it's the same distance. So then our new vertices, we've got J prime, stays the same. K prime becomes 1, 4. L prime becomes 3, -3, 3. And M prime becomes -4, 0. Alright, if we remember our rule, we know that to go from reflecting over y equals x, xy becomes yx. So we can check. So our J becomes 2, 2. If we flip them, we get 2, 2. Our K is 4, 1. If we flip them, we get 1, 4. Our L is 3, -3. If we flip it, we get -3, 3. And our M is 0, -4. So if we flip it, we get -4, 0. And that's reflecting over different lines. See you tomorrow.